Soil pH for nutrient availability and crop performance. This course is brought to you by Gilad James Mystery School. Learn more at giladjames.com. Why soil pH? Soil pH is a master variable in soils because it controls many chemical and biochemical processes operating within the soil. It is a measure of the acidity or alkalinity of a soil. The study of soil pH is very important in agriculture due to the fact that soil pH regulates plant nutrient availability by controlling the chemical forms of the different nutrients and also influences their chemical reactions. As a result, soil and crop productivities are linked to soil pH value. Though soil pH generally ranges from 1 to 14, the optimum range for most agricultural crops is between 5.5 and 7.5. However, some crops have adapted to thrive at soil pH values outside this optimum range. The United States Department of Agricultural National Resources Conservation Service groups soil pH values as follows: ultra-acidic, 9.0. Soil pH is affected by the mineral composition of the soil parent material and the weathering reactions undergone by that parent material. For instance, in humid environments, soil acidification occurs for a long time as the products of weathering leached by water moving laterally or downwards through the soil, while in the dry environments, soil weathering and leaching are less intense, and soil pH is often neutral or alkaline. Soil acidification. Soil acidification is brought about by a number of processes such as high rainfall, crop growth, the use of fertilizers, acid rain and oxidative weathering. Soils usually become acidic under heavy rainfall. This is because rainwater is slightly acidic, about 5.7, due to a reaction with CO2 in the atmosphere that forms carbonic acid. As this rainwater passes through soil pores, it leaches basic cations from the soil as bicarbonates, which increases the percentage of Ai3+ and H+ relative to other cations in the soil. Root respiration and decomposition of organic matter by microorganisms also release CO2 that increases the carbonic acid, H2CO3, concentration resulting to leaching. Soil nutrients are taken up by crop roots in the form of ions, NO3-, NH4+, Ca2+, and H2PO4-. Crop roots often take up more cations than anions. But crops must maintain a neutral charge in their roots for normal physiological processes to take place. H+ ions are released by root crops to compensate for the extra positive charges resulting to acid soils. Some fertilizers such as ammonium, NH4+, fertilizers undergo nitrification process to form nitrate, NO3-, and during this process, H+ ions are released leading to acid soils. Oxides of sulfur and nitrogen are released into the atmosphere when burning fossil fuels. Released oxides react with rainwater in the atmosphere to form tetraoxosulfate, Phi, acid and trioxonitrate, V, acid. Sulfides and other compounds containing Fe2+ produced acidity during oxidation process.